All right, so this is lesson 4 for surface area. Um, and this lesson is really, we're not doing anything new per se. It's just giving us like a context, like a real life scenario, and a word problem that we have to use what we've learned, to like apply what we've learned into this situation. So, um, what you really need to do is just be careful, like be really, really careful of how the question's worded, because it doesn't always mean that you need to count every side. Okay, you'll see what I mean in just a minute here. So this first question is actually really straightforward, but it's really important that you draw a picture for these questions. Okay, if you don't draw a picture, you're going to make mistakes, like pretty much guaranteed. It does not have to be a beautiful picture. It does not have to be a high effort picture, but it does have to be just clear what it is you're drawing. So this question says, Jim has been hired to make a jewelry box. If the box is 12 inches long, 6 inches deep, and 9 inches tall, how much veneer does it take to cover the exterior, assuming no waste? Okay, so he's making a box, and these are the three measurements that we need to know. Okay, 12 inches long, 12 inches long, 6 deep, and 9 tall. So 12 inches long, 6 deep, and 9 tall. And I'm just going to draw my box around that. Okay, so as I said, does not need to be beautiful. Try and make it slightly more clear. Okay, that's our terrible version. Okay, so there's our box. That is everything that we need to know to find the surface area of it. And that's really what this question's asking. It's like we're painting it with a coat. Okay, so what's the surface area that we're going to basically have to paint here? So just like before, we are going to find what are the different sides, find the surface area for each one, and then add them up. So I'm going to skip through some of the work, but I'll just set up the problem for you. Okay, so side 1 is this front side, and it's going to be the exact same as the back side. Okay, if I were to draw in kind of dotted lines here, okay, this front side is going to be the exact same as the side on the back here, this side here. So we're going to have two of those. Okay, we're also going to have the top and the bottom. Okay, the top I'll call side 2, and we also have the bottom that's going to be the same. And we have this side here, which I'll call side 3, and the other side is going to be the same. So we're going to have side 1. Side 1 is 12 by 9. We have side 2, that's the top, which is 12 by 6. This length here is 6. 6. Okay, 12 by 6. And then side 3 is our side, which is 9 by 6. This one is 9 tall, 6 wide. Okay, so we have two of each of these shapes, right? One is the front and back. Two, we have the top and the bottom, so there's two of those. And 3 is the two sides. Okay, so you can find the area of each one of these and add them all together. That'll give you the final answer. All right, so the area of one of these sides is 108, one of these is 72, one of those is 54. So if we're going to add them all up, it ends up being 108 plus 108 plus 72 plus 72 plus 54 plus 54. Get a final answer. Right, just realize you can see that 54 at the bottom there, but our final answer then is going to be 468, and our units here is inches squared. Okay, so this one is just straight up, we're just finding the surface area of this box. The next one, though, we have to be a little bit more careful. Okay, so the next one, it says this person, Anita, is building a greenhouse on the side of her garage. Okay, it's like attached to the side of her garage. She wants it to be 6 feet long, 4 feet wide, and 3 feet high, with the 6-foot side against the side of her house. Or sorry, against the side of her garage. Okay, so when we draw this, you need to be careful. I'm just going to draw like, let's say this is her garage. Yeah, it's the side of her garage. She's building a greenhouse, and she said that the 6-foot side, 6-foot long side, is what's against her house. This side is 6 feet. Okay, and it's 4 feet wide, so that is going to come out then from the. It's going to come out 4 feet, and it is 3 feet high. So I'd go draw up. going to be 3 feet high. So 6 feet is the one that's touching the garage, and then 3 feet high and 4 feet wide. So our little greenhouse thing is going to kind of come out like this. Okay. So looks pretty ugly, but you get the idea. Why is this important? Okay, it says, sorry, what area of glass will she need to complete the greenhouse? And no glass will be used along the side of the garage or for the floor. So what we have here then is, let's draw our greenhouse again. Okay, there's our greenhouse. We do not care about the bottom, and we do not care about the back side here. Okay, so the side that's against the garage is not going to have glass. The bottom is not going to have glass, but these other sides will. So that's the big change here from what we were doing before. Okay, so I'm going to call this side 1. So that's going to be this front side and the back side there. And side 2 will be the top, but we don't have a bottom. And side 3 will be this side, and we don't have the other side. So we have side 1, we have 2 of those. Side 2 is the top. We only have 1. I was going to say times 1. And side 3 is this kind of front side. We only have 1 of those because the back side is touching the garage. So now when we calculate our surface areas, we just need to be careful of how we're counting up our sides. Okay, so I'll kind of skip ahead through some of the work of that. But we're going to be getting our measurements from here. Right? This is going to be 3 high, 4 wide, and 6 long is this side here. All right, so I drew my shapes here. It's a good idea to keep drawing. Draw as much as you can to help you stay organized. So the area of this shape 1 here was 3 times 4 is 12 feet. Shape 2 was 24 feet, and shape 3 was 18 feet. And we have 2 of these. So to find our total answer, like how much glass do we need, what's the surface area of those shapes, we're going to say 12 feet for the first one, and there's 2 of those, so we need to add it twice. And one of these, 24 feet squared, and another 18. Okay, so our final answer then is 12 plus 12 is 24, plus another 24 is 48, and plus 18, 58, plus 8 would be 66. Okay, so 66 square feet squared. So the trick there is just which of those sides are we actually counting. Okay, this one I won't do the example, but I'll just tell you that this one is saying it's a shower stall, and it gives you the measurements. But it only says that we need tiles for 3 of the side walls and the floor. Okay, so one side is not going to be, one side will be the door, so we don't care about that one. And we don't care about the top. We're not going to put tile on the top. So it's just those 3 walls and the floor that you're going to need to calculate the surface area for that one. Right, this one is talking about a cylindrical shipping tube. Okay, so this one is just the same as finding, like you're going to look on your formula sheet and find the surface area, or like use the equation for surface area there. All right, so this one, because it's just the same as what we've done before, if you aren't sure how to go about this one, here's the solution. You can pause your screen here and take a look at it and see if you're able to get the same thing. This thing here is something we haven't talked about. We get our answer in square inches, okay? But then it asks about what would it be in square feet, okay? When we convert inches to feet, 1 inch is the same as, 1 foot is the same as 12 inches. But 1 square foot is actually going to be quite a lot more than that, okay? So like 1 square inch. All right, so this would be 1 square inch, okay? So this is like a 1 inch on that side, 1 inch by that side square. This would be a square foot, okay? A square foot is going to be 12 inches across this way and 12 inches across this way, right? Like 1 foot is the same as 12 inches, and 1 foot this way would be the same as 12 inches. So we can't just say that 1 square inch is going to be the same as, or like 1 square foot is not the same thing as 12 square inches, because if we drew 12 of these things going, that would basically cover one side, okay? Imagine that's exactly 12. That's not the same thing. We also have to go all the way up this way. So basically what happens is you can think of it as having like these inches. There's 2 inches here that we need to convert to feet. When we say inches to feet, we are dividing by 12. But we need to do that 2 times because we've got 2 inches here, inches squared, that we need to do. So times that, all you're doing is divided by 12 again. Okay, this is something we're not going to do very often. It is a little bit more complicated, so don't be too worried if this part's not making sense. But when we go inches to feet, we divide by 12. When we go inches squared to feet squared, right, or square inches to square feet, okay, we have to do it 2 times. Okay, if there's a squared here, we're doing it 2 times. We're going to divide by 12, and we're going to divide by 12 again. And so that's why it says divide by 144 here. That's the same thing as dividing by 12 twice. All right, so let's move on to the last example. All right, so this last example, there's a couple different things about it that make it a little bit more challenging and a little bit more interesting than some of the other ones. So this one talks about Terrence wants to build a shelving unit that costs $6.49 a square foot. Okay, so at the end, like what we're gonna have to do is we're gonna have to find out the surface area of this thing and then figure out how much it's gonna cost based on that. Okay, so that's kind of like we're gonna find out how much material do we need and then times that by $6 and essentially 50 cents to find out how much it's gonna cost. So then it says, how much will it cost him, assuming no wastage, to make a shelving unit that is 4 feet wide by 12 inches deep by 5 feet tall if there are 4 shelves, plus the top and the bottom? Okay, so this is, again, we really need to draw this thing. Okay, so we know it's 5 feet tall, and it's going to be 12 inches deep, which is the same as 1 foot, and we want to have all of our measurements be in the same units. Okay, so in the end, we want to talk about square feet for the cost, and 2 of our measurements are in feet, and 1 of them is in inches. Okay, so we're just going to convert that inches into feet, which is a really easy conversion because if it says it's 12 inches deep, that's 12 inches is the same as 1 foot. Okay. So this would be like our side panel, basically, 5 feet tall by 1 foot deep, and then it's going to be 4 feet wide. So 4 feet wide. Still 5 feet tall. And now here's where it's going to get a little bit complicated. I'm going to draw a dotted line here. This. So when we're thinking of this problem, but like we're talking about how much wood we need for this thing here. Okay, the wood is talking about square feet. It does have a bit of thickness to this wood, but we're going to be thinking of it kind of like how we think of paper being like flat, right? So it's like this side panel here is going to be made out of like 1 piece of wood. So even though we're using surface area to talk about this, it does have like a little bit of thickness here that we just don't care about for the purpose of this problem, right? So basically we have this side panel here, this side panel here, a top and bottom, but then it also says that there needs to be 4 shelves in it as well. Okay, so there's going to be like a shelf going across here. 1, 2, 3, 4, and each one of those is going to be a rectangle. That's going to be something kind of like this, right? Each one of those is kind of its own rectangle. So basically, you're going to have this side panel, 2 of those. We call that shape 1. There's 1 there. You're going to have the top and bottom. So I'm going to call this like shape 2. So the top is also shape 2. And then each one of these shelves is going to come across like this and is going to be the exact same as the top or the bottom. Okay, so we'll have 4 more of the shape 2s to make the shelves. So basically we're having 1, those are the sides, 2 of those, and then the top and bottom and 4 shelves. So shape 2 we got actually 6 of. So we just have to find the area of the surface area of those things, add them all up, and we'll get our final answer. All right, so for our 2 side panels, those ones were 1 foot by 5 feet. So each one of those is 5 square feet. Our shelves and our top and bottom, those ones are 1 foot by 4 foot, so they're 4 feet squared. And then I added one, I didn't talk about this for a back panel. Okay, so if we put wood on the back of this as well, the question didn't really specify whether or not there is. Normally the question should, but I put it on there just for the sake of it. Okay, so that's like a back panel there. So that's 5 by 4 for the back, and so that's 20 feet squared. So if we want to then add up what is the total square footage we would need, that would be 2 for the sides. So that's like 5 square feet times 2 sides. And then these shelves are 4 square feet. We're going to add 4 square feet, and there's 6 of them. So 4 times 6. And then also the back panel is 20 square feet. And altogether then, this is 10 plus 24 is 34 plus another 24. Okay, so we got 54 square feet. Now, this question says that we also want to figure out the price, right? So this is how much wood we're going to need is 54 square feet. And then each one of those square feet costs $6 and essentially 50 cents, okay? So if 1 square foot cost $6.50, then 2 square feet would cost $13, 3 square feet would cost $19.50, and so on. All we're doing there is we're timesing the square feet that we need by $6.49. So we're going to say 54 times $6.49 to give us our cost of this. So our final answer is going to be $350.46. And so that's how much it's going to cost for this shelving unit. Okay. So all these problems, just make sure you draw diagrams, that you label things clearly, organize your work. It's largely, the hardest part is just staying organized and keeping track of everything that you're doing. So good luck with these problems. And this is the last lesson in the unit. Then we're on to the next one. So good luck.